Thank you for joining me. We're going to talk about PL SQL profilers. There are two of them. And we're going to talk about this with a view to doing performance tuning. I'm an independent consultant. I make my living from helping people with their performance problems. And I write about it and I blog about it. And I come and talk about it at conferences. I spend a lot of my time doing PeopleSoft, but PeopleSoft has no PL SQL. And today we are going to talk about PL SQL, so we're mostly not going to talk about PeopleSoft. We're going to talk about performance tuning. And there's really only one question in performance tuning, and you just have to ask it relentlessly. How much time did I spend doing what? And then you go after the things that took the most time, and you keep asking that question as you drill down into the things as you reach the problem. And then whatever it is you're spending time on, you stop doing it. You do it differently. Eventually you get around to saying, well, did you spend some time on one long thing or on many things? And then if it's many things, how many executions perhaps am I doing? What can you do about that? How do you measure that time? Users will say the system is slow. What they mean is it took a long time. So how do you measure that time? And we used to say, the only place to measure time is stood behind the user with a stopwatch in your hand. Not terribly easy to do in the real world. So you find good proxies for it. Logging in the application. Maybe it's web server or app server logging. Maybe it's a batch process that has a start and finish time. So you calculate elapsed time that way. Now that elapsed time is made up of database time and non-database time. So in your classic sort of client-server arrangement, you have client-side operations between the database calls, and then they make database calls where you are busy on the database. And then it depends how much time you spent in each. If it's in the database, well, I can measure it in the database. I can use SQL Trace to measure the duration of my SQL statements. Won't tell me a great deal about PL SQL. I'll get SQL statistics out of AWR. I can get active session history. The active session history will also tell me about individual SQL statements. And if I'm between the SQL statements in PL SQL, I can see which PL SQL package I'm in. But all I really get is, well, you spent time in a PL SQL package executing it on CPU. Doesn't tell you where you are in the PL SQL. And of course, time spent in the PL SQL can involve opening the SQL, parsing it, executing it. And you may do that in different calls, and you jump from call to call. You may go around loops and do this. You may dynamically assemble your SQL and do lots of string handling before you submit your dynamic SQL. And there may just be calculations going on in PL SQL which have got nothing to do with the database. And it's that the PL SQL profilers can help you with, where you are busy in PL SQL but not busy on the database specifically. And even if you are on the database, it can then help you find where in your PL SQL that the SQL came from. Every DBA has had this experience at one point in time. You dig into a problem and you find the SQL statement that is responsible for your problem, and you want to do something about it. And it's not one where you can play with an index. It's not one where you can use a profile. You've actually got to get someone to change the code because the code's been written in a peculiar way, or you need them to do the processing a little differently. So you take the SQL statement and you go around to the developers and you show the developer the code and you say, where does this come from? And they look at the code and you get one of two responses. What you frequently get is, sorry, I've never seen that SQL statement before in my life. I have absolutely no idea where it comes from. That's often the case with dynamic SQL. Or you get, that code comes from a third-party application and we can't change it. But they still haven't told you where it is, which piece of code you have to open up. The first thing you can do about this, probably the most important thing you can do about this, is application instrumentation, so that you can match the database sessions and the activity in them to the application processes, whether it's PL SQL or not. Oracle gave us this package, DBMS application info. One of the things it does is enables you to set two strings in memory in the session information, module add action. And it goes from the session, it gets picked up in ASH, it gets picked up in AWR, it gets picked up in session trace. And you can do lots of things with it. You can enable trace for certain combinations of module and action, like a watch point in a debugger. You can also make it drive your resource manager. You can make certain resource manager groups active for certain combinations of modules and actions. It means you have to put this into your application code. Relatively few packaged application vendors do this. Oracle eBiz does, PeopleSoft does, one or two other third parties I've come across do, but it's rare. And it's unfortunately rare for people to put this instrumentation into their code. When I write PL SQL, which I do occasionally, I might do something like this. I'll make a note of what the current package name is. I will read off the current setting of module and action when I enter a procedure, and then I'll set my value of procedure in there. And then I'll do whatever my code is. And at the end, when I exit from the application, I'll reinstate the previous setting that I saved. So it's like a stack. Every time I go down the function list, I push another module action combination onto the stack and I pull it off on the way out. And because of this on-off arrangement, you need also to put it into every exception. So every exit point from an application needs to reinstate the old module and action. And if you do that in your code consistently, it will let you see where a SQL statement came from, where you have got to in a SQL statement. You know, I'm looking at my session information in $V session. I can see the module action where it is currently executing. Sometimes with a packaged application, you need to be creative. You might, for instance, use triggers to say, well, when a certain piece of data is updated, that means something is going on, I'll set module and action. So in PeopleSoft, with some of the uninstrumented bits of it, when a process starts, the first thing it does is it updates its own status to 7 to say, I'm processing. Well, at that point, I set module and action equal to the name of the process and its unique identifier. So now I've instrumented the application without actually changing the code. The trigger fires in the session that did the update. So that can be quite effective, but and your mileage will vary here. You will do different things for different applications. If you don't instrument, when you profile your time, you don't get any useful information. You know, here we are. 97.8% of my time was spent in the JDBC thin client, which is the default value for module. That's about as much use as a chocolate teapot. I know most of the time was spent in JDBC. I want to know where you spent the time. If you do instrument the application, you get something like this. It's more useful. I can see which transactions in my application I spent the time on. And so here, this 8.7%, well, that's employee name update. So I can see which components in my application, this was PeopleSoft, I can see which components in my application spent the most time. I've got a clue as to what my performance problem is. And if I look at the SQL statements for that application, they'll all have module and action set in the ASH data. However, ASH will not help you with where in your PL SQL you are. Not particularly. It will help you, you know which bits of PL SQL, what time it was, but it won't tell you where in the code you were. So my use case at the moment for this, what got me interested in PL SQL, is I'm working on an insurance application, and it's a core program developed by a third party, and it's driven by metadata, and the customers developed a lot of their own custom functionality, and they've got this massive valuation calculation written in PL SQL. And there's lots of SQL in there, but there's lots of SQL calling PL SQL, and then the PL SQL calls other things, and there's lots of serial calculations. It goes round and round the houses every time. We spend lots of time in SQL. We spend lots of time between SQL calls in PL SQL. I wanted to know where it was. It's still in the database. It's on a database CPU, but it's not executing SQL. So What the profiler does is it takes your PL SQL code and it breaks it into code blocks. And then it tracks which code block has been executed. And it aggregates the amount of time spent in each code block. And then it can roll it up to look at the calling parent to see, well, I spent this much time in the parent, and of that time was broken up into time spent in these children. The profilers write their results to database tables, including PL SQL line numbers. And that's the critical thing. The profilers tell you the line of code that you were executing. Where's the code block? It's package name, function, line number in the package. And even if the code is wrapped, you still get the line number. And this third-party application, they've wrapped a lot of their packages, but of course you can use the Salisberger unwrapper in SQL Developer to have a look at the underlying code. So it'll unwrap it in SQL Developer without unwrapping it in the database server. Now there are two PL SQL profilers in the database, and that's because it's had a heavy makeover in 11G. Both the profilers are absolutely a part of PL SQL. The original PL SQL profiler was introduced in Oracle 8i. It's all based on a package called DBMS Profiler. I got a lot of help when I was first looking at this by looking at Tim Hall's Oracle Base website. If you get the presentation afterwards, you can click on these links. And then in 11GR1, they introduced a new hierarchical profiler. This uses a different package, DBMS HProf. Again, Tim has got some very good information on this. The critical difference with the hierarchical profiler is that it will give you that hierarchy. It collects a lot more data. It also consumes a great deal more memory. And at times, I have had to go back to the old profiler to profile very large pieces of code because we just didn't have the memory available to run the hierarchical profiler with a big enough volume. So sometimes, even though you'd rather use the hierarchical profiler, you get forced back to the old profiler. There is also a coverage profiler. This is not a performance tool. This is a test tool. You know, has my pack of tests which I'm applying to my PL SQL development, has it covered all the code that I've written? And it works in a similar way in that it breaks the code into blocks, but then it tracks executions, and it does that with a different procedure, and it writes to different tables, and there's a different package around it. And there's also pragmas you can define to say, don't track this block. And then you can do a sort of, how much of my code have I covered as a percentage at the end? That's similar but different. It's not something I'm going to talk about any further today. It's not directly part of performance. It's more about development. So you have DBMS Profiler. You start the profiler, you stop the profiler, you can pause it, you can resume it. At intermediate points, you can also flush the data, because when you stop it, it flushes the data. So you've got quite a lot of control with the basic profiler. The new 8 hierarchical profiler, we used to use a script to create the tables in the past, but you don't do that from 19C. You now use create tables. You start profiling and you stop profiling. That's all there is to it. And each time you do that, you get data with a unique ID, comes off a sequence number, and at the end you can analyze it. You get a raw output as well, written in a CLOB. So this is another reason why this actually accumulates quite a lot of data. In both cases, both the profilers, they create tables and sequences to hold the output. You have a choice. You can create them in your own schema where you're working, or you can create one common schema, but you'll need to create a bunch of grants and synonyms so that everyone can use them. The original profiler, you've got 3 tables and 1 sequence number. So you've got runs, units. These are the code blocks, so each code block becomes a unit, and then you have some data about it. The hierarchical profiler, you've got run numbers and trace numbers coming off a sequence. And you've also got this hierarchy table, the parent-child information. This block calls that block calls the other block, and you can write hierarchical queries to retrieve it. And you've got this trace data table as well, which can get pretty large pretty quickly. How do you make it work? It's really simple. You just build a little PL SQL block, start the profiler, run your code, probably just call your own PL SQL package, and turn it off. I mean, you could embed it into your code if you wanted, but when I was playing with it, I just wrote it as a wrapper. Hierarchical profiler, similar idea, turn it on. Do I want the SQL monitor report? Do I want to profile the memory? And then I stop profiling at the end. If I want that report, I have to do a separate analyze. I'm going to show you a demonstration. Now, I'm not going to show you actually run the demonstration because it's kind of boring. It takes 2 or 3 minutes just to run the capture. I'm going to use my own code for this. This is a little PL SQL package that I wrote for PeopleSoft. And it's unusual in that it doesn't really do lots of SQL. It does lots of string handling in PL SQL. But it has the merit that it's mine, it's in the public domain, and therefore I can show you the code. There's no client confidentiality. And it's all encapsulated in one package. I'm not going to actually run the queries. Like all the best cookery programs, here's something I prepared earlier. My profiler is very, very simple. I'm just going to run my code here, and I've turned the profilers on before. Either I'm using the basic profiler or I'm using the hierarchical profiler. I also did a coverage test as well when I was playing around. And then at the end, you stop it in the same way. And then you can write yourself some queries. So there's some setup queries here. You need a table space for it. You need a user for the profiler. I've done it in a common schema, and I've created some public synonyms and the grants, and then I can write queries on it. And then also, if I was using the hierarchical profiler, it's pretty much the same thing. It's just a few different names. Oracle aren't very good at giving you the scripts you need to write so that you can create public synonyms and put it in a common schema. I had to work this out myself. And then you can write yourself some queries. And I'm going to start by showing you the basic profiler queries. So here is a script I ran. You can see the profiler runs. And so here's a couple of runs, and I ran it with different parameters. They took a different amount of time. And here are the code blocks that it picked up. There's various anonymous blocks. If I hadn't created a package, it's just called anonymous block, or it's got a package type on it, and it tells you what the package is. Well, here's my GFC PS part package. And then it shows you all the units in there. And so you can see how much time did I spend in nanoseconds in each block. And you can see, and I've profiled it. So I've calculated the total amount of time in each block, number of executions, what's the maximum time, what's the minimum time, how many occurrences. Well, we executed this block 100,000 times, and we spent 8 million nanoseconds in there. So it's way more than everything else, and it's at line 1239. So I can go and look at the code at line 1239. If I had lots of different packages, you can see which of your packages in an application is being used more. Where should I focus my attention? Where is my time going? Follow the time. I'm very keen on analytic functions for performance tuning. You see, I've got what's the percentage for each of the total time. So just get the time grouped by unit, and then what's the ratio as a proportion of the whole, and what's the running total. And you can see, this execute immediate is 25% of my total problem. And then there's an insert here at a different line number. Well, that's 11% of the total. So there's a few other queries. And so you can see where the time's going. And then you can cross-reference to the actual lines of code. Here, what I've done is I've taken DBA source for my package, and I've left out or joined it, to the profiler table. And now I can see where the code blocks are, and I can see how much time they've taken. So now I have a fairly simple report. Here's the things that take the most time, and then I can go back and look at my source code and say, well, here's what took the time. So each line of code, I know how much time it took. Really simple. So that was the original basic profiler. You can do the same thing with the hierarchical profiler. You can see the individual runs. They get a unique trace ID. You get more information with the hierarchical profiler. You get the function names, and if there isn't a formal function name, it gets given a function name that's generated. So these are my function names, inst line and set action. But then here are other code blocks, and they're given names, and this is line 670 in the package. This is line 868 in the package, and you can see each SQL statement and each code block. It's very similar. You have how much time in the tree, i.e. everything below this point. So where you've got a hierarchy that one thing calls another, as you have here. So here's a PL SQL block, and it calls a SQL block. This function, including the subtree, took this amount of time, and with just the subtree took that amount of time. And so you've got this linked list of code blocks to get you up and down the parent-child, and you can write hierarchical functions on this to report on it. You also get a SQL monitor report that gets emitted to a lob, and you can dump that to a file. I can do a connect by prior query, and I can now see the hierarchy of the code blocks. So you can see that the amount of time in the main call, and then in each of the subcalls, so it can lead you to the right time. And then at the very end, I'm doing the same thing. I've outer joined the profiler tables back to the source. So just as ASH and SQL trace are used to identify your long-running SQL, the profilers expand that view to being the SQL and the time in the PL SQL. One of the nice things about the profiler is that every code block gets given a hash ID. Now that hash ID is just generated if it's PL SQL, but if it's SQL, it's the SQL ID. And that is a reference that you can now take and look up in ASH and in your AWR. So your profiler says, well, this is a long-running SQL. We'll go and look for it now in ASH and AWR. What can I do about it if it's SQL, as opposed to what can I do about it if it's PL SQL? Hugely valuable. And maybe one of the advantages is you don't have to get the developers to actually put the investment in instrumentation, because effectively it's done for you by the profiler. So if you have actually got an uninstrumented application, you can use the profiler to get your SQL and work out where the SQL is in respect to the PL SQL, and then you can find it in active session history as well and do the SQL tuning, or maybe go from active session history back into the profiler tables. So a little trip through profiler. There's some new Boolean parameters on the hierarchical profiler, but they are unfortunately not documented. My current best guess is what they do is that they enable or suppress certain logging behaviors during the analyze phase. It will produce this little SQL monitor active report. You get this report showing you when a trace started and finished, how much time it spent, how much time was in the database, how much time was in PL SQL, what sort of database IO it did. And then for your top SQL statements, which SQL statements was it? And of course, sometimes it's not a SQL statement because it's in PL SQL. So you can get a feel for where your time was spent. So, in conclusion, it's another way of linking the source code and the SQL ID. It's another way of finding SQL in the source. Helpful whether you've instrumented or not. And it might help to indicate which SQL IDs you need to examine in AWR. Word of warning, the profiler, the newer hierarchical profiler can consume a hell of a lot of resource. It can use physical storage while writing the trace to an external directory. It can consume quite a bit of PGA while analyzing the trace. And this can limit how big your tests can go. The older profiler doesn't suffer from this, so there is possibly still a case for using the older profiler as well. I'd encourage you to go out and play with it. This presentation will be made available. The links will take you to the doc and to Tim Hall's pages. The scripts that I've shown you will be bundled up, and they're also available on my own website. Got a few minutes? Happy to take some questions. I've given this presentation before. The presentation is available as a zip file, as a PDF, and in that PDF you will find all the scripts that I demoed today, and it's on the Go Faster website. Look at Oracle presentations, and then under there you will find performance tuning with the PL SQL profiler. Tim Hall's website is also really good for getting to grips with this. It's got some nice little scripts to get you going. Is it a developer tool? Yes, I think probably it is a developer tool. As a DBA, I'm sort of halfway between a developer and a DBA. I'm unusual. I'm a DBA who writes PL SQL. I used to be a developer a long time ago. My motivation was I want to know what's going on. I want to know where the time is going so that I can take time out of my application. That's why I became interested in the profiler. The code coverage tool is an out-and-out developer test tool. You know, the developers want to know, have I tested all of the code that's been written? Can I release it into production because it has at least been run through and been proven to work? That's a different question. Here you're saying, how much time did I spend executing the code? It's more about the performance analyst. Developers also, because the developers ought to know how long their code takes to run, but often, you know, when organizations will turn to a performance specialist to say, help me make my system meet its performance objectives. So it's a tool for everyone. I think we're done. So I'm going to say thank you all for joining me today. Enjoy your conference.